Now, let's take a look at work. Well, remember, work is in the energy family, but let's think it through and see where we're at as far as the work itself is concerned. All right, now, we think about work. Work is going to be equal to, by definition, isn't it the opposite of the change in the potential energy? We learned this when we did gravity, and we're talking about things in gravity land. So the definition of work is the opposite of the change in the potential. And we can look at this later. We'll see that this is absolutely true. Now remember, you can't argue with that because that's the system that's been set up by all the dead people. So when we talk about work, the change in the potential energy is going to be equal to the opposite of the work that we're doing. And then we could cite some examples of that. So if we look there, work is equal to, in our analog, negative M1G H, something along those lines. Now let's go over to electric land. So if we look there, work is going to be equal to negative, and instead of saying M1, we're talking about the charges now. So the charge here is Q, Q1, the little guy. And then GH is like what? Oh, GH, or an analog, is the same thing as voltage. That's a V. So if we look there, the work is going to be equal to negative Q1 times V. Okay, if we look here, something along those lines as well. Now we can gussy it up a little bit if you like. Work we could also think about as negative. Now what is voltage? Voltage is E times R, if we look at that. So if we look there, so we could say Q1, and then here we could say E times R. Now remember, things can be a little bit on the crooked side. So when we look at the work, work itself, it has to be parallel the force and the distance that we travel. So the definition of work, for example, you got to watch out if it's crooked, right? We end up with a dot product, and you have to put in cosine of the angle to make sure that the direction is the same. Just like in gravity land, when we do any work, we have to make sure that the force is parallel with the distance that's traveled. The force only counts in that direction. So the same thing here. If we look here, make sure you compensate for any changes in that direction.